All right, cool. So let's get started. So today we'll be focusing completely on Scala and maybe a couple of time tomorrow as well. So it's a new programming language. In fact, we have done some programs in Scala earlier, but we want to understand right from the learning basic syntax of Scala and how do you write small, how basically you can use that as a programming language and how do you use certain basic elements of that programming language. So it's all about understanding that language. How do you write functions? How do you write classes? How do you call them? How to use different data structures in Scala. So that is something that we are going to cover today mostly. And in fact, in today's session, I would also request people to do some hands-on. Normally, as I said, the trainings we don't really give that time, but this time because we are learning a new language, it doesn't see it's actually theory and practical. But then when we do practical, I would also like some. I will give you some time to do it in your mind as well. People who have not installed Spark Cluster or Cloudera VM, it's fine. They can actually do it on Cloud Lab provided by Simplilearn. But people who already have Cloudera cluster running, they can do it in the cluster itself. I will also show you how to download an Eclipse, a separate Eclipse, which has all the Scala plugins available, so that you don't really need to worry about importing any plugins for that Eclipse, so that you can do it separately. So by the way, you don't really need any any Cloudera VM at all. Even if people who have not done any installation on Spark, you can still go ahead and use this Eclipse outside the Cloudera VM, because all the programs that we are going to do, it is mostly the Scala programs, and those programs, if you want to execute, you don't really need a Spark cluster or a Cloudera cluster. You can execute them as a standalone. So we'll be downloading Scala ID for Eclipse, and that's what I'm going to help you understand. So let me just share the link with all of you, and I will also show you this. I'll share this screen so that everyone understands. So this is what I'm doing, by the way. Basically, as you can see, when you log into the Scala ID, you will get to see this page. Okay, it's a Scala ID. It's an Eclipse for Scala where you can write your Scala program. You just need to do this download ID, and it would basically open your Scala ID page. You can just select the right versions based on your operating system. Okay, mine is Windows 64-bit, so I would prefer to click on this, and you can do as per your operating system versions. Once you download, it will actually get downloaded in your machine, and you need to just unzip it. After that, you should be able to see something like this. Let me just show you that part here. Let me just share this so that you can view this. This is how you can visualize your Scala ID. Once you unzip it, you should be able to see this part, and then inside Eclipse you should be able to see the Eclipse, which is an application. So you can actually just double click on that and start, and it should get started like this. Not really, Shiva, not really. It doesn't overlap. There will be two different Eclipse instances, so you don't need to worry about that. But don't start that Eclipse, because it depends on the Eclipse itself will need a lot of memory. So if you start both the Eclipse instance, it will unnecessarily eat up a lot of memory of yours. Okay, so I would prefer everyone to download this right away based on your operating system, and just unzip it and just click on this portion which I have shown you. This is the Eclipse icon which you need to click once you unzip it. So what happens is it will basically open an ID, and that will have all the required Scala plugins installed. Okay, so that we can basically do a lot of stuff here. And in fact, you can write Java programs also here itself. Okay, all the Spark Java programs also in the same ID. So everything can be done in through this ID. So that's the reason why I would want everyone to have this. Okay. So is that clear, everyone? Any questions here? How to install an IDE for Scala? Well, everyone should have it because today entire session will be focusing on Scala programs, and when you want to write anything, it's good to have an IDE rather than always going to the Spark shell and execute, because it's an ad hoc analysis as we understood in the previous session, and it would not really be very user friendly or a developer friendly when you want to write complex programs. So it's always better to create a class in this ID and then start writing all the programs in that. So let me know in case if anyone has any doubt on this. Sure, Shiva, no problem. Let me show it again. Okay. So this is the link. I have already pasted the URL in your chat window. Okay. So I'll again do that. I'll again, uh, go to that link, that URL. Once you do that, you can see this page. Okay. You just need to click on this download IDE option. When you click on that, it basically opens a page which will involve download link for respective OS. So you will decide based on your operating system, you will click on that particular Scala ID, and download that. So for me, it's Windows 64 bits. I'll be downloading this. Same way you can download based on your respective OS. After that, it just gets downloaded. That's it. And then you basically just unzip it. Then you should be able to see something like this. Once you unzip it, you will get to see this particular location. I mean, once you go to this Scala SDK that you have downloaded, you go inside Eclipse folder. Inside that, you will be able to see this, where there is an Eclipse application available. That's the exe which you need to run. So you just double click and it will start this particular IDE without any project. I have created 2 projects, but for you there will not be any project at all. Okay, so it will be blank. It's an Eclipse only, what we have seen earlier for writing some Spark programs, but this IDE will have all the Scala plugins required, and you can execute it in here itself, in the Eclipse itself. So it will be easier for you to develop everything. And in fact, you can also write all your Spark programs here itself. So that's the beauty of it. That's why I'm saying that you can just use this Eclipse, which doesn't need your Cloudera machine to be up and running. You can just install it outside, and then we will basically understand how to write Scala programs. Is that clear, Shiva? So Sudeep, you can actually go and check here in the help about Scala IDE. You will get to see all the details about what versions of Eclipse it is. Okay. So no problem. Take your time. It's fine. Okay. So that's good, Sudeep. That's really good. Did you download it from the same link which I have shared? So I have just shared that link. Can you just try it again? Just go through this particular link. I'll again share it, and again try to download it and open. It should it is basically a standard ID that they expose for Scala. So you should have all the plugins, required plugins available there. Then it should work, Sudeep. Anyway, were you trying in Scala or were you trying in Java actually? Okay. Anyway, let's not worry about it right now. Let's go with the flow, and we'll start with basics, and we'll execute some of the programs as and when required. So just see if it works for you or not. Cool. So did everyone downloaded it, or anybody is still doing it? No problem. So you can just do it parallelly. It's fine. Let it download. So we can anyway continue further till then. Okay. And just one more time, I want to ask, if someone is not clear with what needs to be done, please let me know now. Right? If everyone is fine, then we can continue. Sure, Sanjay. So this is the link. Okay, fine. So we'll continue. We'll start with introduction to Scala, and we'll obviously start with very basics of Scala. Okay, even though we have written some programs last time in Scala, this is like a session where I dedicatedly wanted to cover only the Scala programming language. Okay, so it's a modern and multi-paradigm programming language for expressing common programming patterns. By the way, it's little confusing words, right? Multi-paradigm programming language, and to just simplify it, it's nothing but it is a mix of both object-oriented and functional programming language. Okay, when you say multi-paradigm means you can actually achieve both either object-oriented or a functional programming using Scala. Okay, and functional programming language when you talk about functional programming language, it is nothing but you are passing a function as a value to the method. Okay, so Shiva, did you have? I think this ID itself will come with the JDK. But did you have any Java installed in that? If you don't, then as you can see from this, let me again share the screen. You need to also download one of these three, JDK 6, 7, or 8, and then you need to configure that path so that when you open the Eclipse, it will work. Then you should not get that error actually. Java failed to create Java virtual machine. If you can just retry it, probably just close other applications and then retry it, it should work actually. Cool. Alright, so yeah, it's a statically typed language. We'll talk about it. What do we mean by statically typed language? It's extensible, provides an exceptional combination of language mechanisms. So basically some of the features of Scala is it's a general purpose programming language, operates in nearly any type of use cases which other language can be implemented. So anything that you can do in Java or C Sharp or Python, you can do it in Scala. So there is no boundary or limit that Scala cannot achieve something which you can achieve it using Java or Python. So it does really support all of the features of both the languages. Multi-paradigm programming language, as we said, it offers both object-oriented and functional programming constructs. It's actually supports statically checked duck typing. So basically, you don't really need. It's a type inference basically. So when you provide a value to the variable, automatically it defines the type of the variable or the value. So Rajesh, it's not about Java EE features. It's about what all things you can do using Java. You can do it. That doesn't mean that all the stuff are as it is, which is available in Java. It is available in Scala. Of course, there is a different way of using some of the features. But Java has, let's say, collections. It has list, map. All these data structures are there. It has threads. All that stuff is there. Same thing is there in Scala also, and you can create classes just like you can create it in Java. You can call functions just like you do it in Java. So all these stuffs are the same, right? Just that syntactically they are different. And Scala is more prone towards both object oriented and functional, whereas Java is only object oriented. Yes, Rajesh, it can be used definitely. It can be used it. I mean, ultimately you need to find out those APIs which are available as part of, just like Java EE features which you are talking, that Scala language doesn't provide, but you need to actually refer to those APIs which are compatible with Scala. So you can write those Scala programs by calling those APIs and make it as a server. Okay. All right, cool. So yeah, that's about it. Now, okay. There is also one important thing that it supports Erlang model of concurrency and powerful frameworks like Akka. So Akka actor-based framework. It is actually it's a framework to handle concurrent thread programming. So you have threads in Java. You have concurrency package which has a lot of APIs to to be used in multi-threading applications, whereas Scala uses such kind of frameworks like Akka to basically be directly used as part of their library. So it has a rich concurrency package actually. Okay, and of course it has a lot of other packages, like you have a lot of collections and list and maps and all that, which you have it in Java. It is available here also. Some of the data types that you have, most of the data types are same as Java. You have byte, short, int, long, double, character, string. Any is a data type which is a super type of any type. Not unit is basically any data type. I mean, it's no value. It doesn't really. So it's like a void. Public void is what we write, right? Which doesn't return any value, which is called unit actually. So we'll be learning that when we do some of the programs. So here they have given the examples also, like basic literals used in Scala are listed below with examples. So you have integer literals, for example, int, long, short, byte. So you type something and it will actually define it whether it is an integer or a byte or short or whatever value it is, or it is a float or double. So as you can see here, you have defined this and automatically it infer the type of it. So you have defined value of big 1.2345 and the output you say double of this. So basic, okay, let me also parallelly do some of the stuff so that you can easily understand it. I'll be using the Cloud Lab Scala editor only. You can also use the Cloudera VM if you have that Scala editor in that. You can, I mean, if you have installed Cloudera VM, you have the Scala Spark shell, you go and then you use that. Because some of the things it's easy to directly write it there. For example, if I do, let's say big is equals to, as you can see, it is defining it as an integer. Okay. But if you are putting some value, some let's say floating point, then it takes it as a double by default. If you put an F, it takes it as a float. So automatically it refers what is the type of this variable using the value that you are assigning to that variable. This is called type inference. It infer the type of the variables once you assign it. Okay. And this is there is a difference between these two variables. Like there are basically two types of variable available in Scala. You can have a where or a val. There are only two types you can do, where or val. Val is more like a final variable whose value cannot be changed. For example, if I just do something like this, 234, it says reassignment to val is failed. There is an error because I already have assigned this value and it is treated that as a final value. It will not be changed at all. You can redefine that variable to take another value. Okay, let's say something else. That is fine. But again, if I try to change it to something else, it will not work. So the idea here is val will be taken when you are trying to use it as a final variable. Okay. Where is a variable which can be used to change the value later. Okay, so these are the two types, by the way, which can be broadly used to categorize to be taken as a type of any variables in Scala. Okay, so that's the type inference stuff that I wanted to talk about. Some of the basic literals you have like characters, so you can also define a character value like this. You can just say, well, a is equals to a, and it refers that as a character literal. Okay, just like you have it in Java. You can also define it as a string. You can just say, well, str is equals to hello. So it takes it as a string class, a string data type. Okay, and then you can in Scala editor you can directly call functions and put the values so that it will give you the results. It might look very simple to the people, but it's just that because we are learning basics, it's important that we cover this. So when you do this, it would basically print your value that you are putting here. Okay, just like that you have Boolean literal. So you can have something like this. It will be treated as a Boolean. So I mean all the data types that we have in Java, we have it here also. Another important thing is Scala. I mean, this is like a, as we know already in earlier sessions, we discussed that Scala is used for interactive and iterative analytics. And when we talk about interactive analysis, it's an ad hoc analysis where we wanted to, let's say, do some operations on certain values, and we want to do it on an ad hoc basis. So it is an ad hoc analysis. So if I, let's say, want to do something like this, let's say where I is equals to 1 plus 2. So it gives me the result. Now if I print I should have the result as 3. So it has already calculated that and give us the assignment as 3. Okay, you can also directly type something like this, which gives you the result as 8. So it acts as an interpreter. So you are basically your whatever operations that you are doing, immediately it will get executed and printed. I mean the output is written. Okay, there are a couple of operators here. There are arithmetic operators, relational, logical operators. You can do something like this, 1 and 2. You can do 1 equal to 2. So if you do this, it gives you the result that it is false. So I mean all these operators are supported that we have learned so far with any language. Okay. Type inference, I already told you that you can infer. It infers the type of any variable based on the value that you are assigning. You don't really need to specifically define it as an integer or a string or a Boolean or anything like that, right? You can define it as it is. Something like this, for example. Okay, so by the way, there is a way to create the classes like this in Scala. Okay, and that's where I wanted everyone to use this editor. So for example, if you really want to use this, let's say I basically want to, for example, here, I mean let's not worry about it right now because we have not yet covered the objects or classes, but here what they are trying to say is any method you define it using def function, and then you give the function name and the parameter and then equal to whatever logic you want to type, so that it will whatever it basically returns whatever it returns, that becomes the data type for the return value. So again, it's a type inference. You don't really define what type it should return. It will automatically infer it from the value that you return of that function. Okay. So there is also some generics that we can use here. For example, if there is I mean this is a concept of Java generics. So if you know generics, you can easily understand it. Otherwise, it will be difficult to understand. So basically, it's a type safety feature. Okay. So if you really want to, let's say, if you don't know what type of your value will come as an input parameter to your method, then you can define, for example, there is a method that gets defined here. Def is always, it's a syntax to define any method. This is the method name, and then there is an argument here. Now I am defining any variable, let's say variable name is X, as a what type? Type is T. T means it's a generic type. So I'm just defining T, which is a generic type here, and then equal to X, which means it always returns the X. So the actual value here is, when you call this basically val q is equal to id1, I'm calling that method, I'm passing 1. So it returns 1 only. So q value will become 1. Okay, because this method doesn't do anything. It returns the same input variable as an output. That's it. Okay, but the internal type, it automatically infers it as an integer, because you have defined here tt, which means it will be automatically referred as integer and integer. So whatever is the type of the variable, the same type I am going to return here. Okay, so this is more with respect to generics, and you need to know a bit on generics. That is a Java concept, but that is also supported here. But however, what we are trying to highlight a point is it's a type inference here. Okay, so a function is a first class value. It may be written as a result, or it may be passed as a parameter. Okay, something like this. Okay, so Dito, generics is a concept in Java. Okay, which will be having lot of it's like, when you are calling a particular method, right, you are defining a type safety in that method. For example, let's say if I think I would have done somewhere here, let me just try if I have done that or not. Let's say this word count demo program that we have written, whatever we are defining under bracket of every object, right? This is called generics, which means I am upfront telling that this particular object, right? It's a pair RDD, for example, but each pair RDD will contain one tuple object, right? And in the tuple, we know it contains keys and values. So the type of the key is string, and the type of the value is integer, and that is something that I am upfront defining it, right? So that Java, or here, by the way, this is actually Java language. So Java compiler will provide that type safety during the compilation time. So now let's say if you do pairs dot add, if for example, if I'm adding, let's say, a string type here, what happens? You can see it gives an error. It says type mismatch, cannot convert string to string integer, which means you are defining a compile time safety that whenever you are adding any object to this particular pair RDD, it has to have a key of type string and value of type integer. I cannot add any other type of key or value in this object. This is called generic. It provides compile time safety, type safety, and which basically avoids lot of errors at runtime because of that flash cast exception or type conversion exception. So generics whole advantage is to make sure your you provide type safety to each value, each variable, to avoid runtime failures. Is that clear? So I have explained you very high level, but this is the whole objective of generics. You can always read about it. Okay, so the function is a first class value and may be written as a result or passed as a parameter in Scala. So you define your functions just like this. Yes, Tito, exactly right. Thanks, Rajesh, for giving an explanation. Yeah, so we were just defining how, I mean, we are just understanding how to define a function. This is how you do it. Basically, you just define a function using a def keyword and give the name of the function here, and then some variables. Let's say I'm passing some arguments to a function, and the argument, let's say first argument is, I'm just giving a variable name as a, it is of type integer, b, it is of type integer again. These are my two arguments, and then the return type of that argument, the value of that, basically whenever you are returning any value from the function, right, what is the return type? So you can define it like this: integer. So now this is the method of that. This is the body of the method, by the way, the code actually. So I'm just doing if a greater than b, return 0, otherwise return something else. And I'm again calling the same function. This is called recursively calling that function, right? So you basically write some logic in this method which basically returns something, and that has to match with the integer as a return type. So this is a, I mean, I'm sure you can easily understand this is the same way you write your methods in any other I would say a program or a programming language, just that some of the syntax would vary here. Yes, yes, Deepak, int is a return type. So Vaishnavi, it is. I mean, the first class was just. I mean, it's a way to define that it's not just a normal value. I mean, I can actually use this function as a value to be passed as a parameter to any other method or any other operation, right? So it is treated as in Scala. You can pass a function as a value, or you can pass a function as a normal function. You can pass function as a parameter. Anything is possible. That's why it's called first class. It's just a way of referring it. For example, if you remember, we discussed one thing. Let me just show you that quickly. I think I have yeah, let me do this. Let me execute one of the RDD. Okay. Now let's say I want to do this. I can basically it returns some RDD, right? So let's say it returns errors RDD. Okay. I'm sure all of you know what is this that we are doing here. It's a line of line with different text, and we wanted to find out how many lines will have good or bad words. So I have a, let's say, RDD created which has those things. We have understood this last time, but I am just trying to show you that how do you pass a function here. So I'll just say RDD dot for each println. Sorry, RDD dot. Oh, it was a spelling mistake. Sorry. So you can see that it has printed this lines right in this RDD. So what I'm trying to highlight a point is this is one function which I'm passing as an argument to another function, and that will be used to process the data for every record here. So I mean this is why it is called a first class variable. So it can be used as a value of a variable, it can be passed as an argument to a function, right? So various ways you can use your functions in Scala. Okay, is that clear, Vaishnavi? Cool. So that's how you define your functions, and in fact, let me just use a normal Scala project here, and I'll be just defining it here itself. So this is my class. What I really want to do here is I want to basically uh, write some function. Okay, so I can do it something like this. You can just define sum of integer, one integer, okay, which also returns an integer. So that is the syntax. Yeah. So Raj, class is just like a class which we have it in Java. You basically write a class to write all the all the properties. Class will have a properties like variables or methods, and then you can call it. So whenever you want to execute that, you have to have a public static void main method. Okay, and that will be defined by writing this object. This is an object which is called a singleton class. You can define anything here, okay, which has to extend app, which means it will be just like having a public static void main kind of stuff. Okay, so as you can see, there is a main instance which will be extending this app. So whenever you want to execute anything which is available in the class, you have to define, you have to call everything here, and then you can run it as a Scala program to execute it. For example, let me show you this. Let's say this is a simple method, and I'll just take this print. Okay. Sorry, this requires unit. We have already defined return type as integer, so I should be just doing this return a plus b. Okay, print will actually return what? Nothing, right? It basically returns a void. So void will be treated here as a unit, but we already said that I am going to expect something as an integer as a return type. That's why I should return something as an integer. So let's say this is a simple method I have. You can actually create, let's say, an object for a duck, and I'll just say object okay. This is a simple class that we are writing, and if we do run as Scala application, it will give me it will print me the result as 30. Okay, so I'm just going to show you how the method can be written. This is a argument. This is a return type. The reason why we are using Eclipse is, as you can see, if I do object dot, I will get all the properties, right? Just like an Eclipse of Java. So for Scala also you can get to see all the properties just like that because of the Scala plugins, right? So it becomes easy for developers to develop. Okay. And then this is a return type. Yes, Mono, yes, it is required because it is just like defining public static void main. Otherwise, you can't execute it as a Scala application. Okay, because this is whatever you write here will get trigger will basically call entire your code. So what I'm doing here, I'm calling an object for this class, and then I'm trying to access some methods of this object, this class, right? So that's why it is going to call that logic by this particular object instance. So that's why it is mandatory. Okay, so that's what a simple demo of using a methods in a class. There is always an anonymous function that you can type, and we'll see the examples later about that. So an object is a name instance with members like methods and fields, right? So you can define an object. So it contains independent methods and fields and create an instance of the class also like this. So I can do something like this. See, this is also one object. If you, for example, if you notice here, there is a class I have created, and I'm going to create this well greeter is equal to new. Yeah, Rajesh, it is fine. No problem with that. You can do that actually. You can define it as well also and try it. It doesn't really make any difference. I'm going to actually see the same result here as 30. Okay. Yes, Pradeep, that's what I explained. So well and where the difference is, one is immutable, one is mutable. One is like final, one is not final. When I say final means now this object I cannot say, let's say, object is equals to new. For example, if I have some other class, duck1, sorry, okay, I would not be able to say duck1 here, right? Because it says reassignment to well is not possible. But if had I define it as a well, sorry, where, then it is possible. Okay, so you need to definitely change that in the hierarchy and all, but it is possible. So where can be assigned, well cannot be assigned. All right. Yes, any further questions anybody has? Oh, okay. I'm sorry, I didn't see that, Rajesh. So let me show you this. Let me open that particular slide page. We already have that slide. You can just do this. Okay, looks like I'm not getting it. Anyway, let me just write it here itself. So you can just define final, and then you will not be able to inherit it. Is that clear? So Rajesh, you can just define a final as a final keyword, and just like uh, the normal Java class which are being final, you can make this class also as final. So the app is just like, either you extend app, which is just like, using a public static void main. So here main inherits the main method of app class. So whatever you do, whenever you define object and extends app, it will internally will inherit a main method. That is the starting point of your execution of Scala program. Yes, Mano, that's a normal object-oriented programming principle. If you make a class as final, no other class can extend it. Is that clear, Sadip? So, Raj, object will be created if you want to make it as a singleton instance. Okay, if you want to, let's say, create a singleton, means a single instance of a class, then you will create an object. Otherwise, you can refer it as a class itself. So, object means it's a singleton instance. Is that clear, Raj? And one more thing, unlike Java, it doesn't really follow any such naming convention where the class name has to match with the file name or the object name has to match with the file name. Nothing like that. You can give any name here. It doesn't really matter. Okay, and you can give n number of classes here. It doesn't matter. So just wanted to show you this. So there is something called trait. Trait is just like an interface object. Okay, so trait is just like an interface, and it's basically define it like this. You define an interface trait as a name of the interface, and then you define certain properties. So where, or where name, where gender, these are the two final variables. Sorry, these are the two properties, and then definition pass exam. So let's say there is one method that it is defined. It's an abstract method. It doesn't have any implementation because it's an interface. Now you will have a class who will need to implement that interface. So you'll define class student extends emp, and that guy extends. You don't really need to say implements emp. When you are even implementing interface, you just say extends emp, and then you are defining that or implementing that entire method in this class, and then you can call it outside. So trait is just like an interface here. Okay, by the way, I'll be actually going through some of the syntax later, step by step. I'm just going to highlight some of the high level APIs right now. Then we'll go to step by step of every small important parameters or functions that you want to use in Scala. So it has collections. Collections are, it's a collection of objects basically, and you have lists, sets, and maps in the collections. List, you can define it like this. Well, X list 1, 2, 3, 4, which means it's a list of 4 integers. You can define set of 4 integers. You can define map like this: key and value, key dash value, key arrow value. So that's how you can create a map of different key value pairs. Okay, you can create tuples like this. Well, X 10 and Scala. Basically, key is a 10 and value is a Scala. So we have already seen, right, how to create tuples in the earlier examples. You can also have an option. It's a container for 1 or 0 element of a given type. Okay, so it's just like an array, but it can also have a 0 or 1 or more values actually. iterator, just like a normal Java iterator, you can iterate through that list of collections. Basically, you can just define here, let's say iterator of ABCD, and then I can say iterator dot has next, and then iterator dot next. So while iterator has any next element, I will be keep on calling iterator dot next to iterate over that collection and then process the values. Okay. List, you can access head, tail, you can check whether it is empty. Those are the functions available in list. There are two types of maps, so mutable and immutable. Immutable is by default, mutable is something which you need to extend from this particular package. Okay, so basically again, mutable means you can actually assign that a map value to some other map object. If it is mutable, that means you create an instance of the map and then you can assign it to some other map class instance with different values. If it is immutable, you can't do that. So just like defining something as a val will make it as immutable. Okay. We'll be seeing these examples as well. Okay. Then of course every map will have a lookup operation like get and put. It will have filter operations. It will have, you can define, you can get the list of keys or list of values from the map. You can remove from the map. You can add from the map. There are various ways you can, it's all these operations are possible in the map. Then there is another collection called stream. Stream class is basically just like a list, but it's a lazy evaluation, which means it will not be executed until you use it. So when you define something like this, it says it's a fib is a type of stream, just like a list of certain values, and then you would assign some values, but till the time you call any operations on that, it will not really execute or create that much memory for that list. So it's a lazy evaluation basically. Okay. So these are some of the basic constructs that you need to know as a developer in Scala. Okay, of course there are a lot more stuff available, and as we say that as we understand, to become master in any programming language you definitely need a lot more practice, but we are just trying to help you understand some of the basic building blocks in Scala. So what I would do is I would actually go through step by step and cover some of the basic stuff in Scala, like how do you use loops, how do you use different variables, how do you assign those variables. Then we'll go step by step creating functions, again calling that functions. Then we'll again go step by step and write some small programs to access certain objects, properties and all, right? So that way it's, I would believe that rather than just going through theory, if we do some small programs, it becomes more clearer for us to visualize and understand. Okay. So what I would do is I would basically now go ahead and start showing you some of the programs. We'll write small programs first and understand those concepts. But before that, is anyone has any question? Oh yes, Raj. I'm sorry. I somehow I'm not seeing the latest questions. I need to scroll down to see that. Yes, it is possible. You can actually extend an object from another object. You can create one more object and then do it. Uh, Shilpa, this is the website you should look for, and there are multiple books actually. You can check any of them. It's not really mandatory to go through each and every book. You can check on any of them and start reading about it. Everything has complete reference on Scala. The first book, however, that you could see in that particular link is definitely a preferred one. Programming in Scala, okay, which has all the basic syntaxes and all the features are covered in that. So this is the link which you should be using it for, learning Scala in case if you want to be proficient in Scala. All right. So let us start writing those programs here. And as I said, we'll start with basics and then we'll go forward from there. Just give me 2 minutes before I start. All right, so let's get started. First thing first is, excuse me, we'll be basically assigning value to the variable just like this. So let me just directly show you that. Uh, One second. Let me open the Spark shell in my Cloudera VM as well. So I have now Eclipse as well as Spark shell that will be running, so I can show you in both the ways so that you guys can also see like we can do those stuffs in both the ways. We all know like how to assign a variable here, but I just wanted to show you one important thing, that you can assign a block expression to the variable directly. Okay, not just like a value, which is very important. Okay, so it is about to get started. So we have seen this. Okay, first is, let's say val x is equals to 10, and I know that it will be taken as a 10, and we know that it is a type inference, so it takes the type of the x is 10. But you can do something like this, a block expression, which means you can do, let's say a is equals to 10, val b is equals to 20, and you will say b minus a. Okay, basically what I really want to do is I want to find out, let's say, the whatever expression you are mentioning, I want to get the result of that, and that is something that I want to assign it to the variable. So you can do this, and now if you type x, it will have 10 as a value. 20 minus 10 is 10. Okay, so you can do something like this. You can write an entire expression, and the result of that can be assigned as a value to the variable. Okay, which is not really possible in Java or any other language, though you can make it possible using some different blocks or writing a methods, but that is still, you have to use those concepts. Here it is called assignment of a block. We can directly assign it to the value. All right, so is everyone clear? Any question on this? just like this. You can also define it something like this. It's like, if x greater than 0 and when x less than 10, 0 else 1. Okay, so basically again if and else loop is what I'm going to define here. Sorry, this should be a different variable. Let's say so I'm taking the original value of x, which is 10. Now I'm defining it is yes, definitely greater than 10, so it is 1. It's not 0. So that's the value you are assigning. So again, any expression you can evaluate and you can assign into the variables like this. Okay. Now just like that, you can also call a while loop and print everything here. Okay. For example, let's say I want to do something like this. Uh, okay, and I need to now actually find the I want to just print every character in that string. I have taken it as a basically a 500 as a value in the string. So this is like a string, by the way. Okay, you could have written something like this also, but it will be very huge. So if I just do welcome, it's fine. Yeah, so that should be fine. Let me just do this while. Okay, you can actually write an expression here. Yes, Swadip, good question. So it did not because they are local. That scope is only for that block. That's why they are not preserved. If you can see, the scope is inside that block itself. That's why you can't use it outside. Is that clear? Okay. So what I'm doing is I have created one string. I want to iterate through that, and I want to print every character in that. Okay, I have defining one variable also here. Now the string, normally when you want to iterate, what do you do actually? You will just say, that dot character at particular value and all that stuff you will do, right? Here you can just define it. I mean, instead of character dot whatever, you can just do this I plus plus. Oh, sorry. I'm sorry. I made a mistake here because again, even I am not really aligned too much to that Java world. Sorry, to the Scala world, and because of my Java coding skills, it hurts me sometimes. So I should be doing something like this. So as you can see, you get all the characters printed for that string just like that. So I'm just trying to show you the loop here. Okay, it has nothing to do with anything else. Very simple, but how do you write a loop here? The reason why I'm showing you everything in this Scala editor right now, because I'm just to highlight a point that you can do those things here also. Okay, it will automatically identify that the loop completes here, then it will execute that entire loop. Otherwise, it will be showing the pipe symbol here, which means that particular command is not complete. Yes, sorry, because it's a for loop. Otherwise, again, it will say that the variable is not initialized. So you have to define a default value to that. Okay, so Deepak, this variable is at the global scope that I'm defining. In a normal class, if you would have defined that, it would be available for that class scope. If you have defined it in a method, it would be available in that method, or the block, it will be available in that block. So the scope remains the same. More or less, it's the same thing which you know in any other programming language, in Java or any other. So right now I'm defining it at a global level. I'm not defining that variable at in a particular class level or a method level. I'm defining it in a global level. So now it is accessible till you are there in this Scala prompt, Scala session. Okay. Yes. Any questions as of now? I know it's simple, but let me know in case if there is any question. Okay. Now the same thing you can use, of course, a functional programming language part here to do it in a little better and a concise manner. I can just do this args dot. I can use a for each loop. Okay, for each argument do this. Okay, remember this syntax that we used to do in earlier programs that we have done for RDDs and all the operations. This is like for every element, right? Use this, do this, right? So for each is a transformation for RDD. I mean, it's not right now. It is not a transformation or anything. It is just a loop. But I was trying to relate it with the RDD thing. When we were applying any transformation in an RDD, we used to say that this is an object and this is the particular logic that you need to execute for that object, for every object in this RDD, right? Same thing here also. This is basically a functional programming syntax that we were using it in earlier examples of RDDs. Okay. Right now we are not really relating it with RDDs or anything because it's a pure Scala programming language. But last time we have used some of them, so that's why I just wanted to correlate. One more way of doing it is, instead of all this, I can just do this, which will also yield the same result. Okay, it will tell me the same thing, that okay, I want to print everything one by one. Okay, if you just do this, it will print everything together. So anyway, this is actually the same as whatever you have defined earlier. So either way works here. Okay, that's about for each loop, and then you can traverse through array, and you can actually find the, I mean, you can basically work with an array, or again a string also. So if you really want to, let's say, calculate the occurrence of this string, you already have I, right? I will assign it to 0 again, and I already have arguments which contains welcome. I want to find out the length, so I can do this way. For there is a for loop also, okay, which you can use for I, which is basically, for me, it is 0 until args dot 0 until, I mean, args dot length will also give you that. In case if you want to do some other operations, you can do it like this. I'll just write it this way: for I is equals to, oh, I'm so sorry. It was not I. It should be something else that I need to write here. you get the total characters as 7 in this string. So likewise, you can do many operations by playing with the array. Okay, in this. You can also define different collections here. So I'll be showing you some of the basic collections like arrays and map and all that stuff. Let me just do it here. Just give me one. This is about defining an array of integers of type 10. So it will give you default values of 10 like this. Okay. Same way you can define an array of type, let's say, string. Then default value will become all the strings as nulls. Okay. Or you can, instead of doing this, you can create something like this. Let's say n is equals to array okay. So this should give me the result as an array which contains these two strings. So you don't need to define a size here. Dynamically you can add it here. Okay, but array, as we know, is a fixed size collections, right? It's a fixed size. You can't add any further elements in this because the size is fixed, right? You need to create a new array with those elements. But what if I want to create a dynamically growing array? Then how should we do it? So there is something called array buffer in Scala. Okay, you can actually use that, by the way, array buffer. So let me just show you that part here, how to do that. So we'll be using, let's say, a same syntax as this. Okay, this should give me the okay. So it says not found value array buffer because I need to import somehow I'm making a lot of spelling mistakes these days. Okay, so it has created a mutable array buffer, okay, of type int. Now, what is the use of that? When you do this, my A is a mutable array buffer, right? Now, if I want to add new elements inside that, okay, I can do this. For example, I want to, let's say it is of type integer, right? So I can actually do this. Adding can be done by plus operator. It is not just incrementing. It is also adding that object in an array. So if I do this, it should give me array buffer of 1. Now you can see one value is added in that array buffer. Okay, I can also do something like this. I want to add a group of, let's say, more elements like 2, 3, 5. As you can see, it is appended. Now it has 4 elements, 1, 2, 3, 4, 5, right? So likewise, you can dynamically add new elements in the array buffer. Okay. You can also do this. Which basically gives you, if I just do A, it should give me this. You are basically modifying the array, adding the new array, adding the particular object at a particular index. So I'm adding this value at this index. Likewise, a lot of stuff are possible. Okay. So I can show you this again. This is how I have done that, Raj. Is that clear? This is how you created an array buffer. So the memory management is actually, see, for example, okay, let me take some time to explain this. It's actually very similar to all the other programming language. Just give me 1 minute. Let me open the whiteboard. See, what happens here is, let's say, for example, you have an array, okay, which has, let's say, 4 elements. Now, when I want to add a new element in this array, it will not be able to add it, not possible, because the memory is allocated for only 4 elements. Now, if I want to add it, what you have to do, you create a new array of, you will increase the size automatically, let's say to 10. So now I can fit 10 elements here. Okay, so you will first copy these objects 1, 2, 3, 4, and then the fifth one I copy the fifth element which I'm going to add, and of course there are still more space left, but when all of them are filled again, you have to again copy that. So system.arrayCopy is an operation where you create a new copy of array, you dump all the elements in that, and then add extra space to that. So there is a lot of, it's actually a performance hit. When I say performance hit, it basically creates a new array with lot of space, copy all the elements from the older one to this guy, release this memory. So there is definitely a performance hit in terms of copying all these objects to this new array, right? And then it satisfies you that operation. Whereas in array buffer, it actually does not, I mean, it internally follows this only. So what I'm trying to highlight a point is, programmatically, if you want to achieve this, you have to do it by yourself, but array buffer takes all of this internally, takes care of all of this internally, right? So it has created one array with a default size. For example, let's say 10. We don't know what is the default size. Normally it is 16, but you can assume that it is, let's say, 10. It will have a capacity to hold, let's say, 10 elements. Now you can keep on adding them. For example, let's say you have completed adding 10 elements. Okay, after that you want to add a new element, but you know that it's an array buffer, so by default it should be a dynamic one. But internally, when you want to add an 11th element, then what it does, it will first check if the size is full, it will create another array. Okay, increase the size by 10 more, so now array size becomes 20, and then copy all these elements here, and then starts adding another new element from here. Okay, so likewise everything will be happen internally, and this is what is being managed. This is called memory management. So it takes the new array, copy all the elements from the older array into the new array, and then remove it. So see, your native data structure is still array only. It is not, there is nothing, no data structure as array buffer. It is a you know, a one I would say a wrapper API which is given to you as a developer, so that you can play with it and think of it as a dynamic array. But internally it has to do this operation only. Is that clear? No, not really, Swadeep. In fact, array buffers are, fine. You are fine to use it any number of times because they actually, so this copying of the elements to the new array, right? This is internal. I mean, this is the core of where they use a lot of memory to shuffling these objects and all, which is basically that's where the Java runtime engine, because Scala is also running on JVM, so that interpreter is I mean is performance wise it is really highly optimized to do this operation, so we should not be worried about it. You can use array buffer even for large data. In fact, for a large number of data you need to use array buffer only. You can't use array because you don't know the size. Oh, I'm sorry, Raj, actually. So first of all, to answer your question, yes, this is like adding a 9 element at an index 2. Okay, that's why we have added a, it's like 0 index, 0, 1 and 2. So the third position I'm adding 9. Then what I did, I keep on adding new elements, because there was a question that can we add more elements at the end? Yes, we can keep on growing this array because it's a dynamic array. So just by doing this, I can add more and more elements and it keeps on appending it. Is that clear, everyone? Cool. So, okay. So Shiva, not like that actually. So you need to really, okay. It will be something like this. Okay. Initially, let's assume that it's internal. We don't need to know about it. But since you're asking, I'm explaining that. Initially, it will have, let's say, 10 elements of an array. Array, not array buffer. Array buffer is also implemented using a data structure called array. So it takes 10 elements. It added, let's say, 3 elements. 1, 2, 3 here. Okay. You are saying 5 elements. So I'm just taking 5 elements. Now you are saying next time if I add 7 elements, does it take? Yes, because it's a dynamically growing array, it will take, but what it internally does, it will add, let's say, 6 and 7, and remaining 5 elements when it has to add, it will in fact create a new array by increasing the capacity, double it by 20, and then copy all these elements here, all 1, 2, 3, 4, 5, 6, 7, and then add 8, 9, 10, all these things, whichever are the leftovers. So this is happening internally. Developer does not need to worry about it. The moment you use array buffer, this happens internally. Is that clear, Shiva? So it is able to take it up. Okay, so let's now use the same as array. We will use another data structure called maps. Okay, so I can do this variable of let's say my map. And it you can put the key values just like that. Okay, initially, so map doesn't really have any limit. You can put any key value. Let's say key is k1, value is, I'll put it as v1. Okay, key is k2. Any object you can define, by the way, here. Okay, value is v2. Let's say I just want to add this. Now what you need to do, if you really want to access something like this, for example, I want to access a value for the key k1. So what you should do, I'll just say x is equals to my map dot. In fact, yeah, you directly specify key only, k1. Okay, so I'll assign the value to this variable. Sorry, it was a lowercase letter. If I type x, you should have the value defined here as v1, right? So that's how basically you access the value for the given key. Now there is another important thing. You can actually do the same thing here. For example, if let's say right now I'm defining this, but for example, if I do k3, that key is not present, right? And we already see what happens. It throws an exception saying that it's not present, no such key exist. So in that case, I want to safeguard my program from failing. If key doesn't present, it should not really throw me an error, but let's say it should throw me some default value. So what I would do is I'll just say where x is equals to my map dot get or else. Okay, that's a method available, get or else, which defines something like this. It will say key k3. If it is not present, give me something else as a default value. That's it. So it will not throw an error. Now what happens if I do x, I will get 0 as a result. So because key is not present, okay, otherwise I can actually do this k2 and it should give me the value v2. Now I got a v2 value because that key was present. Okay. Now I can also do something like this. Excuse me. So one important thing which I wanted to show you is when you do this, what I'm trying to do, see, minus means I want to delete a particular key from the map. But this guy says, sorry, I can't let you do that because it is not a it is a member of immutable map. So by default, any map is an immutable map, and I think somewhere here we read that in the PPTs. If you notice, this is the one. If you can see here, this particular slide, we discussed that it is an immutable map, and it is there are two types of map: immutable and mutable. Immutable means you can't really change anything in that map. Okay, so here I am trying to exactly do the same thing. I'm trying to remove a particular key from that map, but it basically says, sorry, I can't let you do that because it is an immutable map. That's the difference between mutable and immutable. So now if you really want to make it as a mutable, you really need to create another instance like this. Okay, for example, I can do, well, my map is equals to it is part of collections in Scala. Okay, and there is something called mutable map. Okay, and here I need to define this K1 V1 K2 V2. Okay, so I'm now defining or creating an instance of this guy, which is a mutable map, not like an immutable map which I had. So this time, whatever operations I have done, it works fine as it is. Earlier the same way, but when I do this, it should not give me an error. It says fine. I have actually given the smaller k. Let me do this bigger k. So as you can see, it has removed that entire entry whose key was k1. Right now, only k2 v2 is there. Okay, this is called mutable map, which means I'm creating a new map with a new key value pair, or I can edit, delete any key value, add any new key value like this. You can just do plus. Sorry, I can just do this plus, and I can put, oops, plus v3. This is, let's say, k3. Okay, so basically what it means is you can add anytime a new key value also in that map. So this time now map will have a new key value added. Okay, so is everyone clear with playing with map and difference between mutable and immutable? Any question here? It's a random order, Manoj. We can't predict the order. It may be in the beginning or at the end. It's a random order. So in map, it doesn't really follow any order because you really want to access based on the key. So Raj, well and where are same? Yes, because it is still referring to the map object. But then I cannot refer, when you do well, I cannot create another instance of map. That is not possible. That is why it is well. But if it is where, I could have assigned it to some other instance of map. Okay, so the same object, same reference variable can refer to another object if it is mutable. If it is not mutable, it cannot refer. That's the difference between where and well in the context of map. Yes, any further questions on map? Okay, same way you have another famous collection like list. You can just do list is equals to list of, uh, you can do something like this, one, two, sorry. So I can do list dot, it's like a linked list. Okay, by the way, when you create this, it is using a linked list. So this is your head, this is the next node like that. It is a linked list implementation. So likewise, you can do lst dot till everything is give you the elements as it is. So that's how you can play with list. We have already seen one list example, if you remember, in the last session where we wanted to do some parallelize, right? And we have used that actually. So parallelize of a list will create an RDD, as we remembered the last time. So these are the different ways you can play with the collections in your, I would say, Scala. Not really, Rajesh. So we just have map, and then internally it takes care of using mutable, immutable map and all. So hash table is not required here. There are, however, certain APIs available in the concurrency package which takes care of concurrent hash maps and all that, but not like hash table. Hash table is not really useful here because it has all the functionalities. Map has all the functionalities which you have it in hash table as well. Yes, Rajesh. As I said, there are implementations based on the methods. You can say, set, and then you can create an instance of the set, and then you can call some sort APIs on that, which will help you to do the sorted set implementation only. So not exactly you have it in Java. You don't have these classes separately, but you have those methods in those objects which helps you achieve those implementation. Okay. Now let me go back to the Eclipse and let me show you some little bit more programs on that. I mean, we'll be creating a class and we'll be using some methods. I hope all of you know that we have getter setter methods in Java. I mean, we can create, in fact, getter setter method like object in Shilpa, another couple of minutes and then we'll do it. So we can actually create a getter setter method in Java, and then we will basically same way we can do it in Scala also. So I'll just show you that. For example, let's say I want to create uh, a particular class. Let's say I want to create a counter class. Okay, and I'll show you what I'm doing here, and let me just write it first. So what I have defined is this is called getter setter methods in Scala. Okay. I have basically defined a class which contains one value of one variable basically. Okay. And I want to set the value of this variable because its scope is private. I cannot access it from outside world. So I want to set the value of this variable by calling certain methods like setter methods in a class. So this is called a setter methods. And I'm just incrementing the value. You can pass some variable here and you can increment it. You can assign that variable here. That is also possible. Okay. Uh, and let me kind of write it here. Setter. And I can just do this. So I can pass a variable and then I can set it to this, or I can increment to that variable. Anything is fine. All right. And here I'm just returning it. This is called getter method. So when I just say define current function, I don't have any body here. When I just do equal to some variable, that means it is returning that value. That's it. Okay. So that's a easy way of writing a method without any body. It just returns. So it would be in Java you would probably mean something like this, right? Uh, Return value, right? And it returns an integer, but right now it is basically, yeah, right now it's not possible here because it doesn't really have that. I can actually do, I can instead of writing this much actually, which is also possible, but as I said, there are too many lines of code. So instead of that, you can just do this equals to value, which is simpler way of writing. So that's why Scala is, more concise way of writing your logic than Java or any other language. So I'm just showing you certain differences, which gives you a good idea about why it is concise and why it is easier to write. I would not really right now call it as easier because people need to definitely get a lot more familiar with this. But once you get familiarity and experience, yes, you find it more easier. Okay. Yeah, so we'll be basically doing, let's say I want to call this particular method. Okay, I want to call getter and setter method in my class. So I will just use an object. I can just, let's say, I can write any object by the way, just to extends add, sorry. Okay, just like a public static main. And then you will create an instance where object is equals to new counter. Okay, you will just say object dot setter 10. I want to set 10 value to this value and then I want to get it. So I can just do print. Okay, print ln object dot current. That's it. If I execute this, you all know the output here, but I'm just showing you a getter setter method how to use that in Scala. Another important thing which I showcase you here is the scope of a variable. When you define something as a private, you can't access it outside. For that only we need a method like setter and getter to access the value of that variable of a class from outside that class. Right? So once I have getter setter method, I can assign the values like that and I can retrieve the value of a variable using this method itself. So I hope everyone is clear with that. Any question here on this? The getter setter methods are very useful for many operations. That's the reason why I'm showing you this. Oh, so the getter setter methods are like, this is called a POJO object. I mean in Java, basically plain old Java object. So you can define certain, DTO objects or certain bean objects which will just contain certain attributes, and then let's say you want to just access those objects. For example, let's say you have a list of transaction objects. Okay, I have, let's say, or let's take an example of employee data. I have a class employee which contains employee ID, name, and age, okay, or salary. These details I have. This is my class, okay, and I want to represent 100 employees, and I want to put those data, and then I want to find out those employees who has the highest salary. I want to find out only the one employee who has the highest salary among 100. Okay. So when you want to do this program, right, you would first populate these objects. You will create those objects, right? This is your structure. And when you want to create an object, you will have get and set method of all this field, each of this field. Okay. So you will create employee, object 1 is equals to new employee, right? And then you will set something like this, object 1 dot set of ID, name, salary. Like that, object 2 you will create, which will have its own salary value and everything, right? And then what you will do, you will just say list dot add all the objects, object 1, 2, 3, like that, all the objects you will add, all hundreds, and then you will try to sort it based on the salary with different comparison logic. So there are a lot of applications where you want to play with objects and you want to sort different objects. You want to find some, you want to compare basically two objects. And when you want to do that, you will definitely need, see, when you want to compare two objects, you will compare it based on certain attributes, right? And that attribute is nothing but one of the variable that is available in that class, the class from which you are creating that object. So it should have a getter setter method so that the comparison becomes easier. So that's why we should have this getter setter method. Is that clear? Okay. No other questions, right? Anybody? So Rajesh, we are going to cover only those basic programs today because it's more on focusing on writing programs in Scala with the basic building blocks. I'll be slowly taking more examples, more problem statements. I'm just covering basic building blocks right now. Then I'll take some problems. Okay. So do you want to try this small program which I have just tried? I know it's simple, but it's okay if you can try it in the Eclipse and just get your hands dirty before we move forward. Okay, sure, no problem. Now I'll be showing you one more concept of constructors. I'm sure everyone knows what is a constructor. Constructor means when you create an instance of a class, it will basically create an object and it will call the constructor of this class. So let's say I'll create a new class here. Okay. So I want to, let's say, you know, right, that there is always a constructor which gets called when you create an object. Okay. Now you may have a default constructor by default that is available, but you can have an argument like multi-argument constructor as well. For example, let me define this class test2. Okay, and I'll have one variable, let's say a value. Let's say some name, better name I'm giving it. Let's say one age of this class is what I'm giving here. And then I want to do this. So I want to override a constructor like this. I'll define this. And then I'll give a variable to this constructor. That means it's a one argument constructor, and I'm sure people will understand this. You will call a default constructor here, and then you will say this dot. Okay, let me define another value as size, and then I'll say this dot size equals to size. Okay, this is one constructor, and same way I'll be having, let's say, one more constructor, size and age, and I'm going to define both the variables here. Okay, so what do we achieve here is we are actually having two different constructors, which makes a call to the default constructor. This is mandatory. Yeah, Shiva, I'll be mailing all this code, don't worry. Okay, after this session. So we will have different constructors which internally calls a default constructor. That is a mandatory thing. After that you can define something. So this is called parameterized constructor. People who know or who have worked on any object-oriented programming language can easily understand that. So I can actually define this object test. Oh, sorry, there is already a test I have defined. So cool. Now it basically, you can create an instance like this. Let's say object1 is equals to new of test2. That's a default constructor. Object2 is new of test3. Sorry, 2, and pass one variable. I'm creating three different objects, okay, using three different constructors. Okay, one I'm creating it with a default constructor, one I'm creating it with one argument constructor, which means this particular method will get called. Another one I'm creating it with two different variables, so this particular constructor will get called. Then what you do here is you will do something like this: print the values. So it will be something like this: object1 dot age and object1 dot size. Okay, so I am printing all the values. We'll just see the changes in the variables for the respective objects. Okay, if I execute this, let me see what happens. See, first it is 0, 0. Why? Because it's a default constructor. So default constructor does not, it will have a default value 0, 0, right? So it gives me 0, 0 as a result, because object1 is of type default constructor. Object 2 was type first argument constructor, one argument constructor. So it has set the size, it has make size as 10, but age was default 0. So that's why it is 0, 10. Okay. And the next one made both 10 and 20. It has changed that. So that is why it is 10, 20. So that's how you can actually make, you can create multiple parameterized constructor, and you can call them as much as you want. And you can, do further operations on that. So is this clear with everyone? How to work with constructors? Yes, Deepak, absolutely right. If you don't pass anything, that's what I'm doing here. It is calling default constructor. So Deepak, unlike Java, in Scala you will always have one default constructor, even if you overload certain other constructors. This is called constructor overloading. You don't really have constructor overloading like concept, but you are basically defining constructor with different arguments. But still there will be one default constructor which is available here. Okay, so you don't need to worry, it will always be there. Any questions on this? Yes, Deepak. If you don't define, the still default will be there. This is what you are asking, right? I don't have any constructors defined, then I will have a default one picked up. I have commented out all the other code. Any further questions anybody has on this? Yes, Manoj, that's right. So if you don't really need to write all this public static void main, you can just do extends app. It will work fine. All right. Any more questions? Okay. So what we can do is we can take a break now. We'll come back after half an hour and then we'll continue forward. Okay. So see you all after the break. Okay, we can start now. So we'll be working on traits. We'll understand how to create traits and how do we uh, solve the problems using traits. How do we implement traits in Scala? So traits are just like an interface, as you can, I'm sure all of you know how does an interface work. So the same way you can actually implement traits in Scala. So let me first use a demo on traits and show you how do we achieve that. I will be creating an interface first. Trait. Let's say I'm creating a logger as a trait, and that has a method called log. Let's say, for example, which takes a message and it basically does nothing. It's an abstract method. Okay. This guy extends logger. Okay. And then we will have a concrete implementation of this method. The log will again take the message as a string, and it basically just, let's say, prints the message, nothing much. And then let me extend so we'll be basically executing that. I'll create a logger instance from the new trait demo, excuse me, and I'll be doing this logger dot log. Okay, because I have a log method which should print this, so it just say this is trait demo. That's it. So now if I execute this, I should be able to see the traits being used, and this is how basically you implement the interface. Okay, so that's about how do we use a trait. Now you can have multiple such interface and you can actually use it as it is. You can have one trait extends another trait, and you can inherit all the methods from those traits in the class which implements one trait, one particular trait. Okay, so this is basically a trait demo which shows you how to use a trait. We call it as a trait, but it's an interface for Java, for example, where you have methods defined in an abstract form. It doesn't have any implementation defined here. As you can see, I just have a log method which takes one parameter as a message, as a string, which doesn't have any concrete implementation, and I have another class which takes a log as a method, and it prints the message here. Same way, there is a implementation class which basically calls these methods by creating an object of the trait demo. So that's how we use interface in Scala. Okay, any question here? Anybody? Okay, so am I audible, everyone? Okay, so looks like one person is not able to hear me. Okay, sure. So let me do that. Let me repeat, Deepak. So trait is just like an interface. Okay, this is an interface. Interface will have methods defined in that, but they are not really, interface doesn't have any methods which are having a concrete implementation. They are abstract, which means they don't really define any implementation. They just say what needs to be done. They don't say how to do that. Okay, so anybody who is going to implement the interface, any class who is going to implement the interface needs to basically define the implementation for that methods, and they need to say how are we going to do this. So this is, let's say, a trait which I'm defining it as a logger, and the utility of logger is to log messages. So I'll just say log messages, but what exactly or how exactly it should log, that is not defined. So I will define one class who implements this trait by giving a concrete implementation of this method log, and there it defines that okay, this is one message, this is how I'm going to print it. So this is the implementation basically, and then we are just using that, we are just calling those class objects and the methods so that we can execute it. So that's how we can use a interface in the form of trait. So there is no interface as such in Scala. Everything is trait, and you need to extend the traits and implement the methods and then call it wherever you need it. Is that clear, Deepak? Okay. Now, for example, let's say there is another class, okay, which says trait let me show you the both the ways. Like a class can also extend another class. I mean, I'm basically showing you an inheritance functionality here, which is one of the important features of object-oriented programming. So how do we do inheritance in Scala? That is what I'm showing you here. So I'm just defining another class. Let's say uh, we already have a trade demo. So I need to just say okay. So as you can see, what I'm doing is now I have another class, okay, which has a log method implemented. There is an interface which says there is a log method which needs to be implemented. Whoever implements this interface, which is a trait. Now I can have a class who extends another class with an interface. That is how you can do it. Extend a class with an interface. You can do it like this. And ideally, I should give a log method implementation in this class, right? In this trait demo class. But I'm not doing it. Why? Because already if it extends logger util, I already have that method implemented here. So you can just, when you extend another class, you will inherit that property, right? So even if now also if I run this application, I should be able to see that particular output. This is a trait demo because I can still call a log method which is available in the super class. Because I'm extending it from logger util, I can do it. And once I extend it, I will have that method available in my class, which means when I implement this interface, that method is all by default implemented. Okay, so that's how you can use inheritance in Scala. You can extend another class, you can implement another interface as well using this. Okay, I can also have my own method here, any other method. Let's say any other method which which can do any other implementation. So we don't really be interested in knowing what it does, but this is what it is. So this time, if I do logger dot any other method, I will get this result. If I, let's say, create an object from logger util, okay, then I can call object dot okay. So what I'm doing is I'm creating an instance of the super class, and I'm again calling the log method because like it is defined here. But if I want to do this object dot any other method, definitely it is not available because the superclass doesn't know anything about subclass, but subclass knows everything about superclass, right? So this is just a normal inheritance concept, and I'm sure many of you are aware of that. So if you run this, you will get to see both the statements printed here. This is the trait demo. Then I'm calling another method of the subclass which does something, and then I'm calling the log method of the superclass, which is this. Right, so that's how you can use interface and objects together. You can have one class extends another class, and you can basically do inheritance this way. Is this clear, everyone? Any questions here? So Gagan, with logger means it is implementing, it is inheriting this class with this interface. So it's like in Java world, if you want to understand, extend a class and implement an interface. That is what we mean by this. So with means you are also implementing that interface, which is a trait. So it is, I mean, do you like, I mean, if you, can we also define at logarithm? Yes, yes, you can also use something like this. Extends, if you do this way, for example, logger, then I don't need to even do this. Okay, because your superclass already implements an interface. So the subclass will already get, by default, it will also implement that interface. Okay, and still everything works as it is. So Manoj, it's if you have worked on any object-oriented programming, wherever you use interface, you can use trait in Scala. Okay, it's basically interface are for abstraction. It's a concept in object-oriented programming language, abstraction. So you use interface so that you can hide the implementation details behind the methods. So I can actually write an interface and I can just say this is what I need to do. Now whoever is going to implement that interface will define how to do it. My interface will be just to the outer world that this, if someone really use my logger interface, he will just know that this is having a log method, right, which means it is doing some logging. But how that logging will be implemented, that depends on the class which is going to implement that. So I mean, in the scenarios where you want to make more loosely coupled programming, I think if you have worked on any Spring or any such framework, you would know this, that programming to interface is the best design for any programming, which means you should always try to loosely, I mean, try to have less dependency between the classes and objects, and each class should know about any other class very minimum, and they should know each other by using interfaces. So when you say programming to interface, it actually gives you a better design and it gives you more flexibility to change the implementation, underneath implementation at any point of time, without changing the entire application code and without impacting others who are really using your code. Okay, for example, let me give you a real world scenario. Twitter as a source, Twitter is exposing, let's say, tweet data. Let's assume that it has a method called get tweets, okay, for every second. Now assume there is a trait something like this. Let me just write it here. Let's say my interface is Twitter, okay. And I have a method called tweets, get tweets, let's say, okay. It just gives me the array of tweets. Okay, so this method will return an array of all the tweets. Now as a developer, right, this method, for example, let's say this interface is exposed by Twitter itself, And for me as a developer, I want to get all the tweets on every second basis. You can just define here, let's say one parameter, let's say a time interval, and I'm just defining it as a string right now. Sorry, string. Okay, so I want to get the tweets on what time intervals? On a daily basis, hourly basis, every second, every minute. That interval I will define. Now behind the scenes, it is the headache of Twitter, how they have implemented these tweets and how do they give that tweets to me, right? My whole objective is I want to use this interface so that I can just call this method in this interface and pass this parameter so that I can keep getting those tweets based on this interval. Now let's say today I am getting it on a daily basis, for example. Now Twitter would have implemented this method where it would, let's say, call certain business logic that it has written, and then it goes to various other sources in Twitter itself, because Twitter tweets are stored in a distributed environment in different NoSQL database, so it hits different sources and then brings the data. Now tomorrow, let's say they have changed the architecture underneath and they are now storing tweets in only in let's say one centralized place rather than storing it in a distributed manner. I'm just giving you a hypothetical scenario. Now when they change this underlying architecture and they, let's say, change some implementation to get the tweets, okay, from centralized place rather than getting it from a distributed environment. Now that is the logic, that is the complete change in their API, in their method which they have implemented. But as a user or a consumer of this method or this interface, do I really need to change at my side? If that is the case, where any changes that you need to do at your side would impact all your clients also to do the changes at their side, that means it's a bad design. And when you do design by programming to interface, which means when you expose your interfaces in such a way that the contract of the methods or interface remains the same, then client or consumers of your interface are not impacted at all. Only the person who's going to change the implementation, he will have to, it's his headache to kind of do it. So Twitter has to change the implementation to get the data from the centralized store rather than a distributed storage. But as a user, as a user of or consumer of this tweet or this thread or this interface, I don't really need to change any of a single line of code, right? So that is where interfaces are used mainly. Whenever you want to expose your APIs to the outer world, you should use interfaces. Is that clear now? Thank you, Manoj. And when I gave you this example of trade and each trade can extend another trade, okay, so you can now assume that way. So we have already seen that, and that means you can work like that. So there is no difference here. One trade can extend another trade, can extend another trade, like that. Now, for example, there is a scenario where you want to, let's say, I want to, let's say, implement this method also, this interface also, which is, let's say, Twitter itself. Okay, I want to log also and I want to implement this Twitter. So for example, I'll be writing another class, Twitter IMPL, okay, which extends logger. Let's just forget this is not needed. Okay, so the Twitter IMPL is extending the logger util because I want to extend this class to log all my messages. At the same time, I want to implement a logger. Let's say the logger util is yeah, I want to implement the logger interface, and I also want to implement the Twitter uh, interface. Okay, so as you can see, it says an error that needs to be an abstract since method get tweets in trade Twitter of type this is not defined. So either I make this class as abstract, or I would basically use I have to basically implement the method called get tweets because I am implementing this interface. So what I'm trying to show you here is likewise you can actually implement n number of interface using this with one interface with another with another with another. You can extend one class, implement many interface like this. Okay, and I can just define here, let's say get tweets uh, time, and of course it returns array of string. Okay, so you can just do this. Okay, so I'm just okay. So Deepak, that is like it's def is a method signature. I mean, it is just like a method. It is not just definition. It is basically any method will start with def. It's a syntax actually, which signifies that this is a method. So you need to provide that. Okay. So I'm actually showing you here like how a particular class can extend one class and implement multiple interfaces and then implement their methods. I mean, this is how you can do it. And for example, you can just excuse me, just get the tweet instance. Yeah, that should be fine. So then you can take it as one array and then you can just iterate through it. We have already seen that, so it's fine. Okay, so that's how we can basically do it. So I'm just like trying to help you understand how do we use this different interface. I mean, how one class can implement multiple interface using different width, and then implement their methods as and when required. Okay. So any questions here as of now? Sure, yeah. Okay, so get with is basically we can have different body for the same method in different class. Yes, yes, Dipto, that is possible. You can override that. You can, for example, do something like this. Is that what you are talking? You can do something like this. And then you can define overridden. You can actually do this. So this time you can check which method will get called here. Okay, it will be actually calling the superclass because we are extending the logger util. But if I call here tweet dot log, and if I give the same message, let me just take it as message only, and then if I run it, it should be able to call this subclass method, overridden method message. This method gets called. Even though it extends logger util, it has this method, but now I have overridden that method and give the different implementation. So now it is using my overridden method because I am creating an instance of the subclass. So it will basically call that particular method. Is that clear? Oh, Sudeep, actually, I mean, I have just explained you, right, that you pass some time interval and then I'm not really implementing it to the full list. I have just given you some dummy code here. So you can pass any junk value here. I have just passed one. That's it. I wanted to basically show you how to use a different interface, how do you extend different interface and implement them. So what we are learning right now is we are just seeing different varieties of OOPS concepts, like how we can achieve it using Scala. Okay. So any further questions on this? Sure, no problem, Sudeep. It's fine actually. You can ask me anytime. Okay, there is one more example that I wanted to show you, which is how to read a file content. Okay, we want to basically understand how do we read the contents from the file. Excuse me. So that way we will cover that portion as well. Apart from this, give me 1 second. So let me open another class. I'll be just creating a class for file. So you are doing basically a file operation where I want to read data from a file. Okay. In fact, you can just do this instead of writing all the classes and everything. I can just do this. You can just have a main method as it is directly, and then you can define all the contents here. So let me do one thing. Let me just create one file. Okay. I'll just copy paste one simple file here. Just give me 1 second. I'm going to read it from the package which is Scala IO. So you need to basically import Scala IO first. This is the location where I'm actually copying my file. I'll show you the location where I have put the file, by the way. Okay. So that we'll do it tomorrow. Okay. So right now, yeah, this is how we. Okay, let me first show you the Scala example itself. This, I mean the file that I have created here. You can see here there is a test file that I have created. Okay, so if I open this, this is the test file, which this is the basically the test content, which has just one line. Okay, this is the test file to be read from Scala. I have just created one test file. You want to read this? I'll copy this entire path, by the way, and you are going to basically see it from the Scala program. So this is how basically you read the file. So I have copied this entire path, and I will also make it. Okay, I will directly do this, so it's easier in Scala rather than doing all the, that buffered input stream, file reader, file writer. All this stuff is not needed here. Just say get this thing and just say mixed string. That's it. Okay. So I'll be creating a file, and then I'll just print the file content. Okay, if I run it, you can see that it has been able to run the file from that location, and this is the content that I just read it. Okay, so this is how you read the data from a file from the hard disk. Okay, and from file will take the path of the file which you have created in a location, and then you can just use that as it is. So basically this is just one example of how to read the data from the file, and you can use this Scala IO package. Just wanted to show you this package which will deal with all the file IO programming, how to read the data from the file and all that stuff. Sure, Manoj. Is that clear? So any questions on this? Okay, so that's about uh, uh, Scala code that you need to write. Swadeep, since you're asking, actually, let me do that right away, because I understand you can actually get some time to practice as well. So I can show you the code here itself about. Give me 1 minute. I think we have written some code, right? I don't want to type everything. I'm sorry for that, but we have already done a lot of hands-on demo earlier. So let me just copy paste from some other existing demo so that I can show you how to write a Scala code using that RDD example. I mean, I'll just take one small example of, let's say, word count. I'll just take a jar out of it and then we'll execute it on the Cloudera cluster. Is that fine, everyone? So that you'll get a feel of how do we do that using an Eclipse in Scala, and then how do you create a jar, and then how do you make it executed in Spark cluster. So that's fine with you, right? That's what you're asking. Just 1 second. Let me just take this code which I have. All right. So let me create a new class. It's a Scala class. Just give me a minute. Hello everyone. Really sorry there was some issue at my end. What I would request is, since it's already like 11:20, I think I'm actually getting some issue, frequent disconnection, and I got some error in my VM Cloudera cluster as well. So is it okay if I can show you that demo tomorrow? And meanwhile, you can just let me know in case if you have any questions. I'm really sorry for this trouble. I just tried to open that VM, but it actually got crashed, and I'm getting some weird error, so I need to just find it out what is the problem with that. But meanwhile, please ask any questions if you have, so that we can actually leverage this time. I can actually be available for some more time so that you can ask any questions and we can do that. I'm really sorry for this one trouble, but we'll make sure that tomorrow we'll complete that. Sure. By the way, meanwhile, let me just open the poll so that you can fill up the poll. Not really, Swadip. As I said, I don't have any references who has actually cleared the latest Cloudera certifications. But what I can do is I can suggest some guide to you, and I can actually help you. I mean, if you have any questions while you're preparing, you can always post those questions to me, and I'll help you clarifying those answers. Okay? Because I don't have any contact as of now who has cleared that. Sure, Swadip, no problem. I'll do that. Anybody else has any other questions? So I'll be sharing all the code, by the way, which we have covered so far. You can just go over it, and you can actually get experience on that. Just try practicing it on your Eclipse. It will give you a good idea on how to work with Scala. Yes. So thank you everyone, and whoever wants to leave, you can leave. Actually, we are done for the day, and thank you for your time. We'll meet tomorrow at the same time, and we'll continue forward. Okay, everyone. So thank you and have a good day. We'll see you tomorrow at the same time. Yeah, sure, Dipto. That's the reason why I keep it that way, so that everyone was having a good time to understand basics. Because sometimes jumping onto the complex stuff will not really help. Right. And the next week, when we go on to the advanced concepts of Spark, which are Spark SQL and streaming and MLlib, that time it should be easier for people to understand, because we have covered almost everything as far as Spark core is concerned. And I also wanted to cover, Scala, and mostly I wanted to cover the basics of Scala, because Scala is a huge area, and you will learn it as and when you practice it. but at least the basic thing, if it is covered, you can understand now how to build on top of that. Okay, so if no questions, we can call it a day. Thank you everyone for your time and really appreciate. Okay, sure. So we'll see you tomorrow at the same time. Thank you. Have a good day.